So this video is going to talk about phosphate. So phosphate, again, as you'll remember, all living things are CHO, N, P, K, and S. So the P is phosphorus, and all living things need the element of phosphorus to survive. The way plants will take up phosphorus is typically in the form of phosphate. You can see the formula up here. It's capital P, capital O, subscript 4, 3 minus. So it's an ion, and plants get their phosphate or their phosphorus by phosphate, which dissolves in water, and the plants take it up. Animals by what they eat. That's how they're going to ingest the phosphorus that they need. And again, recall the phosphorus cycle. I said phosphate. It's the phosphorus cycle, actually. Recall that in there. So that's what phosphate is. Phosphate is a nutrient then that is often applied to farmland. So your sources for phosphate here are fertilizers. Organic fertilizers, so dead plants or humus, inorganic fertilizers, again, primarily like pellets that are man-made, that are like little white pellets that are put on the land, or septic tank waste, poop. All of those, again, if you recall, the organic fertilizers, the decomposing organic matter, and the septic tank waste or the poop are, again, there's organic matter. All living things have phosphorus in them. And then when they're decomposed by bacteria, they're converted into phosphate. And so that's super important to remember. Again, goes back to all of those basic ideas of that. Detergents used to be a big source of phosphate. They really added to detergents. They added phosphate because it really whitened stuff. They don't do that as much now, but they had used that quite in the past. And why did they get rid of it from detergents? Is because phosphate had the environmental impact almost identical to that of nitrate, except the big difference is it's a limiting reactant in fresh water. So if I dump a bunch of phosphate into a waterway, so a farmer applies a bunch of fertilizer, it runs off into the waterway, it could cause issues in the river or a pond or a lake nearby there. And basically, you're going to get it's a limiting reactant in fresh water. You're going to get that algae bloom. So what is an algae bloom? An algae bloom is this big growth of algae. And then what's going to happen? Eventually that algae is going to die. Aerobic bacteria are going to do aerobic respiration. They're going to break down that algae. They're going to decompose it. They're going to, in that process of aerobic respiration, they're going to use up the dissolved oxygen. The DO is going to go down, and it can go too low, and it can kill fish. So exactly the same as nitrate. All of this is identical to nitrate, except phosphate tends to be more of an issue in fresh water. Nitrate tends to be more of an issue in salt water. So we see like the dead zone in the Gulf of Mexico, that salt water tends to be more caused by nitrate. In fresh bodies of water, that the issue tends to be more associated with phosphate. The other thing I noted here is the other way sometimes it can have an impact is algae, remember, does photosynthesis and respiration. That goes back to the ideas of NPP and GPP. Algae does photosynthesis and respiration. However, it only does photosynthesis when there's light. So it's always doing respiration, and it only is doing photosynthesis during the day. So at night, or actually as you're getting really close to sunrise, what has happened is the oxygen in the waterway is slowly going down as the algae there, after an algae bloom, is doing respiration. And if that oxygen level gets too low, it could kill fish. Because again, just like we can't hold our breath for an hour, fish can't do that either. And again, why is it an issue in waterways? Because the dissolved oxygen levels are super low to start with. DO is like 8 parts per million is a good level, and that's 0.0008%. So that's super low to start with. It doesn't take much, and it's too low, and it's going to kill fish. So big idea. I underlined it here, and this is kind of what the College Board seems to point to. But that's how the algae bloom, limiting reactant in freshwater, is for phosphate, causes an algae bloom. The algae eventually die. Aerobic bacteria, totally natural, do aerobic respiration, eat the algae. DO goes down, and if it goes too low, it can kill fish. Human health impacts of this is none. Basically, in reasonable concentrations, anything you're going to see in nature, there's not going to be human health impacts associated with that. I hope that was a helpful explanation about phosphate.